Hello, hello. Today I want to teach you about similar triangles. Nice short topic title. Go ahead and make it the short topic title on the next free page in your math notebook. When you've done that, close it up, turn on that brain, and I'll tell you when it's time to write. So you'll notice I put the word similar in quotes here. It's because it's one of those words that it's a math word. Much like many other words we have learned over the years, there's words that just mean something different in math than they mean in normal life. Like compare in math, it means greater than, less than, or equal to. In language arts or any other place in the world, it means kind of like talk about their similarities and differences. Totally different words in math and in real life. Difference, in math, it means the answer you get when you subtract two things. In regular life, it means, what's different about things, totally different. Variable is usually like a letter in math that represents an unknown value. And variable in every other part of life kind of means changing, or, can vary, can change. Constant is a number that is added to something in an algebra problem. In math, in real life, constant means like not changing or happening all the time or something like that. So words mean different things in life and in math, and the word similar is no different. So I'm going to teach you about similar triangles today. So I want to tell you what that word means in math. It is not the same thing that it means in regular life. So triangles that are similar, let's start without any math, just looking at them. The gist of what similar means, as you'll see in these these four examples here, is they're the same shape, so to speak. Not just that they're triangles, but they're the exact same shape of triangle. Like this one has like a right angle and then a longer side, right angle, longer side. They're the same shape, but they're a different size. So they sort of mean like this one's too. You can see these are the same triangle. They're both this equilateral triangle. This one's just larger and this one's just smaller. So it's sort of like a bigger or a shrunken version of the same triangle. Even these two are similar. They're not oriented the same way, but if you were to kind of rotate this one, you would see that it's a similar triangle to this. It's a smaller version of this one. So that's like the quick idea of what similar means. So we would say these two are similar, these two are similar, these two are similar, and these two are similar. Not all triangles are, of course. These are not. Well, these ones might be, but these orange ones, like this isn't just this is a shorter version of this triangle, but it's not the same triangle. They have both have this same side. On this one, the sides are taller, but this is like a flatter, smooshed version of this triangle, but it's not the same shape triangle. These two, obviously not. These two, obviously not. They're just totally different triangles. These two actually might be, I can't tell, so I'm going to X those out. They might actually be similar, but those are not. So that's what similar means. It means they're the same shape of triangle, but a different size. Let's get to the math behind what similar means. So these two triangles are similar if you look at them. They both have a long side at the bottom, and there's sort of a fairly flattened from the top isosceles triangle. We would say these are similar. They're the same triangle, so to speak, or the same shape of triangle, but a different size. Now let's talk about the math behind that. So triangles that are similar, and these are, will have two features. First thing to know about similar triangles is you'll notice all of their angles are the same. This one's got two 30-degree angles and a 120-degree angle. This one's got two 30-degree angles and a 120-degree angle. That's going to happen when triangles are similar, is that their angles are going to match. So that's the first feature. That's the first math feature of similar triangles, is they have all same angles. That's just what's going to happen if you if you take this triangle and enlarge it, or take this triangle and shrink it. The angles won't change. The lengths of the sides will change, but the angles won't. So that's one feature of similar triangles, math-wise. The other one that you'll notice has to do with the sides, and that's this. the sides change in an equal ratio. So you'll notice here, this side is 4 times the same side over here, times 4, times 4, times 4. So that's what also happens in similar triangles. So their angles will always match, and their sides will always change in the same ratio. We're going to be focusing on this side one, or this angles one rather, mostly today. All right, so kind of a question you might be asked is like this: are these two triangles similar? They look fairly similar. They are slightly different sizes. They look to have roughly similar side lengths compared to each other. So are they similar? So we're going to check this with math. So remember, the two things we can look for are all angles the same, or I also could look at, are the sides in an equal ratio? That one I can't tell on this. They didn't tell me any lengths of any sides, so I can't really use that one on this one. So I'm going to have to use this. Are all the angles the same? So I do see that they have a 100-degree angle. That's a good start. I have two other angles here. I need to know the last angle in the triangle. So let's see, if this one's 100, this one's 45. That's 145 plus the other one would be 180. So I think that is 35. So we'll put that in there. Over here, 135 plus the other one would equal 180. And that would be 45 to make 180. So they are. So in this case, when I find the missing angle, all three angles in these triangles match. So they're slightly different. This one looks a little smaller. They're slightly different versions of the same triangle with the same angles. So these would be, yes, these are similar because all angles are equal. One more I do before we move on. Let's do one more. How about these? Are these two triangles similar? So remember, we can either look at their sides or their angles. Again, here, no sides are given to me. So I'm going to have to check their angles are all the angles equal. That's what you want to know math-wise to know if they are similar. So let's check it out. Each one I've got two. Good start. They each match on one angle. I'd have to rotate them to see if they look similar. So let's check the other. So here, 70 plus 58, that's 128. Plus this other one is 180. Let's see, that would be, I think, 52 if my math is right. And over here, 70 and 40, that's 110. So that's going to be 119 for the first two. Plus the other one makes 180. That would be, I feel like I'm going to mess this one up, 62? No, 61? Is that right? 120? Yeah, I think 61. So this one, we've got a no. They look fairly similar, and you'll notice their angles are very close, 49 and 52, 58 and 61. They're only off by a couple degrees, but they're not quite the same. So we would say these are not similar. All the angles don't match. All right, find that notes page I gave you, and let's look at some here. So the first thing you'll have is what similar means, or examples of similar. So check these out. Similar, if you want to add this definition without the math, kind of means they're the same shape, but different size. Is kind of how those work. So all of these are bigger and smaller versions of the same triangle. Here you'll notice these are not oriented the same. So this one you'd kind of have to rotate to see that these were similar, but they are. These are not similar. So these, even though they both have a 60-degree angle, you can tell they're not just different sizes of the same triangle, and these aren't even close. Again, they have the same angle, but that's it. They're not the same triangle. So that's what it means, like just to look at triangles and see if they appear to be similar. But let's make sure we have our features. So the next part of your notes page, you've got this. So please write with me on there. There's two features of similar triangles. One, all the angles match. Anytime you have similar triangles, the same shaped triangle but different size, the angles will just be the same. The angles don't, if we took this one and like expanded it to be the same size, the angles wouldn't change. We would just get a bigger version of the triangle. And then the second feature is the sides all change in the same ratio. In this case, it is ×2 or ½ depending on which way you went. So this side and this side are twice as big or half as big. This side and this side would be twice as big or half as big. This side and this side twice as big or half as big. That's a feature of similar triangles too. Whatever their size difference is, it's the same ratio on all the sides. So that's what the features of similar triangles are. That's the math behind what makes triangles similar. So two quick examples. Let's get some here. Are these two triangles similar? Let's see. I already see one same angle. That's a good side. We're going to need to see if all three are all angles equal. That's what we're looking for. So this one, let's see, I'd have 125 plus the other one is 180. And I think that would be what? 130 would be 55. I think that would be a 55-degree angle. My mental math is right. Good looking sign there. And then this one, 25 and 55 is 80 plus the other one make 100. And 80, I'm sorry, 180, which means this side is indeed 100. So these are similar because all angles are equal or congruent. We use the geometry term. So that is an example where they are. Hopefully I got a good example here where they're not, just so we can get the hang of that too. Are these two triangles similar? You'll notice a good start. They both have an 81-degree angle. But when we find the other one, I think we'll find that they're not. So let's check here. 80 and 60 is 140, so 141 plus the other angle is 180. So that's going to be a 39-degree angle. And over here, that's 121 plus the other angle is 180, which is going to make this, I think, a 59. Look how close these are. 60 versus 59, 39 versus 40. They're so close, but not similar. There. And that, y'all, is what similar means in geometry. There are other similar things too. You can have similar quadrilaterals. It's not just a triangles thing. That's what it means. It means the sides, the angles have the same measurement and they are different sizes in the same ratio. Hope this made a lot of sense to you. If not, check it out again and I think it'll help. If it did, you're all set and you can move on to the next thing and I'll see you next time.